Close your eyes for a second. 40,000 men, 7 years of labor, 350 miles of wilderness, no bulldozers, no asphalt, no concrete mixers, just iron tools, human hands, and a standard that demanded perfection. Every stone cut to specification, every layer compacted by hand. The roadbed is 4 feet deep in places, and these men dig, haul, level, and pave through forests, mountains, and swamps using technology that wouldn't look out of place in the Bronze Age. By every law of modern engineering, this should take decades. It should cost billions. It should require an army of machines. But here's what actually happened. They finished ahead of schedule. The Via Appia, built in 312 BC, still carries traffic today. 80% of its original basalt stones remain in place after 2,300 years. And the real surprise? It's not what they built with. It's what happens when you compare them to the most advanced highway systems in the modern world. Systems with billion-dollar budgets, computer modeling, and industrial machinery, and still fail within 20 years. Interstate 35W, Minneapolis. August 1st, 2007, 6:05 p.m., rush hour traffic. A steel truss bridge that had carried thousands of vehicles daily for 40 years suddenly fractured. The main span collapsed into the Mississippi River. 13 people died, 145 injured. The bridge had been inspected, analyzed, and deemed acceptable just 2 years earlier. Modern engineering, modern materials, modern safety standards. Catastrophic failure in 4 decades. During the reconstruction, a single pothole on the detour route cost the Minnesota DOT $3 million to properly repair, accounting for traffic management and proper base reconstruction. That same year in Rome, workers resurfacing a section of the Via Appia removed the modern asphalt overlay and found the original Roman stones beneath, still perfectly level, still perfectly drained, still doing the job they were designed for 2,000 years ago. Same planet, same weather patterns, completely different outcomes. So what did the Romans know that modern civil engineering never figured out? Before we get into the system, let's deal with the myth. Hollywood gave us an image. Slave armies whipped into submission, bodies breaking under stone, roads built on suffering and conquest, monuments to imperial cruelty. The archaeological record tells a completely different story. Vitruvius, a Roman military engineer and architect writing in the 1st century BC, documented something that clearly surprised modern scholars when his texts were properly analyzed. These roads were built by skilled professionals, free laborers, paid craftsmen. Roman law required that workers on public projects receive fair wages, standardized rations, and medical care. The legions that built the roads were soldiers during peacetime, performing engineering duty as part of their service. The wage records from Vindolanda, a Roman fort in northern Britain, survive on wooden tablets. They list payments for road work. They detail bonuses for difficult terrain. They account for tool maintenance and material quality. These weren't the records of a slave operation. These were the logistics of a professional workforce that understood their value. Now, the question becomes sharper. How did a civilization without modern machinery manage to build infrastructure that outlasted everything that came after? The answer isn't one innovation, it's a system. And every layer was more deliberate than it appears. Start with the roadbed itself. Archaeologists have excavated Roman roads across 3 continents, the Via Appia near Rome, the Via Domitia in France, the Fosse Way in Britain. Ground-penetrating radar has mapped roads still buried beneath modern streets. And across every excavation, every scan, every cataloged cross-section, the same precision. 4 distinct layers, each engineered for a specific purpose. Total depth, 3 to 5 feet, depending on terrain and expected traffic. As modern engineers have documented in comparative studies, Roman road builders made ruthless design choices. Every element served drainage, load distribution, or longevity. Anything that didn't earn its place was eliminated. Speed of construction fell into that category, not because the Romans were indifferent to time, but because the road's design already solved the problem of permanence. Here's the principle. The foundation layer, the statumen, consisted of large stones set directly on excavated earth, sometimes on wooden piles if the ground was soft. This layer alone was 12 to 24 inches deep, hand-placed, not dumped. Each stone positioned to transfer load to the earth without shifting. Above that, the rudus, a layer of crushed stone and lime mortar, 9 to 12 inches deep, packed down until it formed a nearly concrete-like mass. Then the nucleus, finer gravel mixed with hot lime, 12 inches deep, smoothed to a precise camber. The surface crowned in the center, sloping toward drainage ditches on both sides. The grade never exceeded 3 degrees, water sheeted off within seconds. And finally, the summa crusta, the surface. Polygonal basalt stones on major roads, fitted so precisely that a knife blade couldn't slip between them. Each stone hand-cut to interlock with its neighbors. No mortar on the surface. The stones held themselves in place through geometry alone. But here's the detail that separates this from simple over-engineering. The drainage system itself was part of the structural design. Every half-mile, culverts channeled water away from the roadbed. Stone-lined ditches, 3 feet deep, paralleled both sides of the road. The camber, the crown, the ditches, the culverts, they formed a single integrated system. No standing water, no freeze-thaw cycles breaking down the substrate, no erosion undermining the foundation, a constant natural flush. Now, compare that to a modern highway. Asphalt laid over compacted aggregate, 6 to 12 inches total depth on average rural highways. Drainage designed for cost efficiency, not longevity. Water infiltrates cracks, freezes, expands, the pavement lifts, potholes form. Within a decade, resurfacing is required. Within 2 decades, base reconstruction. Modern road, cheap, fast, and temporary. Roman road, expensive, slow, and eternal. And then there was the engineering culture. Roman roads were built to a standard, not to a budget. The specifications were public. The Via Appia required stones no smaller than 18 inches across. The Via Flaminia demanded a roadbed no less than 14 feet wide to accommodate two-way military traffic. Inspectors, appointed by the Senate, measured and certified every mile. Contractors who delivered substandard work faced financial penalties and public disgrace. The roads carried the builder's reputation forever. Modern highways are built to budget projections and political timelines. The lowest bid wins the contract. Materials are sourced for cost, not performance. Inspections happen, but the incentive structure rewards speed and economy over permanence. We know this, we've seen it, and we keep doing it. There's a genuine debate among historians about how much of Roman engineering was intentional brilliance versus practical tradition. Some argue the Romans understood, through generations of observation, that deep foundations and integrated drainage kept roads operational across centuries. Others say it was simply the way they'd always done it, inherited from Etruscan and Greek road builders before them. The evidence can support both readings. Where do you land on this? The roads were only half the equation. Roman engineering didn't stop at construction. Over 80,000 kilometers of paved roads connected every province from Britain to Syria. A network of maintenance stations roughly 15 miles apart, the distance a courier could cover in a day. Every inspection was a structural reset. Drainage ditches were cleared. Displaced stones were repositioned. Worn sections were replaced with identical materials using identical methods. The biological and geological burden of time simply never accumulated. But the real genius wasn't in the maintenance. It was in what the Romans did with their standards. And this is where the gap between Roman engineering and modern construction becomes a gulf. If this kind of depth is what you come here for, a like genuinely helps us keep going. The word viae publicae, public roads, carried legal weight in Roman law. These roads belonged to the state. Way Truvius's manual, De Architectura, specified exact construction methods down to the angle of drainage slopes and the composition of lime mortar. Every engineer, every contractor, every legion building roads in Gaul or Germania or Africa worked from the same playbook. The standard held regardless of location. Quality was non-negotiable. Daily inspection was mandatory. Those standards weren't guidelines, they were requirements backed by law. What comes next is the part of this story that rarely gets told. The difference between Roman engineering and modern construction wasn't about knowledge or technology. It was about something far more powerful. Modern engineers know how to build roads that last. The technical knowledge exists, the materials exist. We could, tomorrow, build roads to Roman standards, but we don't. And here's why. The Via Appia cost approximately 450 million sesterces to build over 7 years, roughly equivalent to $500 million in modern terms for 350 miles. That's $1.4 million per mile. Modern interstate highways cost between $5 million and $30 million per mile, depending on terrain, and require full reconstruction every 20 to 30 years. We spend more and get less because the incentive structure has inverted. Roman contractors built for posterity. Their work carried their name. Modern contractors build for profit. Their work carries a warranty period. Now, picture yourself driving on Interstate 95 through Connecticut. Expansion joints every 50 feet. Pavement patches in 3 different shades of asphalt. Potholes filled with cold mix that will wash out in the next freeze. You know that feeling, the constant low-grade vibration of a road surface that's never quite smooth, never quite right. If you've ever commuted on deteriorating infrastructure, you recognize exactly how this feels. You know that infrastructure decay is a choice, not an inevitability. Medieval Europe tried to maintain Roman roads after the empire fell. They failed. Not because they lacked the roads, but because they lacked the system. Without the engineering standards, without the maintenance network, without the culture that demanded excellence, the roads themselves became ruins within centuries. The knowledge didn't die because it was forgotten. It died because the culture that enforced it collapsed. And the consequences arrived in the 20th century, the age of the automobile. The American interstate system, begun in 1956, connected a continent within 2 decades. These were the largest civil engineering projects the modern world had ever mounted. Asphalt surfaces, minimal drainage engineering, designs optimized for construction speed and initial cost. Below those surfaces, insufficient foundation depth. Water infiltration and freeze-thaw cycles caused failures faster than any budget shortfall ever could. Roads that survived a decade required resurfacing. Roads that survived 2 decades needed base reconstruction. Some never made it that long. The I-95 corridor in the Northeast has been in continuous reconstruction since the 1980s. Billions spent, permanent construction zones, no end in sight. Meanwhile, near Rome, the Via Appia still carries local traffic on original stones laid before Christ was born. 2 civilizations face the same engineering challenge, the same weather, the same geological reality. One embedded quality into culture, the other left it to market forces. The results speak across 2,000 years of history. Picture a Roman road crew at dawn. A surveyor sights along a groma, the bronze crossstaff that ensures perfectly straight alignment. A stonemason kneels beside a basalt block, checking the fit against its neighbor with hands that have shaped 10,000 stones. A crew foreman inspects the camber with a water level. Fresh lime mortar is mixed in exact proportions, documented in manuals copied from engineer to engineer across generations. Vitruvius recorded every detail of this process. He described methods that modern engineers have tested and found flawless. The intent was infrastructure. The execution, by every measurable standard, achieved permanence. And that's worth sitting with. The Romans had no computer modeling. They couldn't simulate stress loads or predict material fatigue. But generations of observation, encoded into standards, produced an infrastructure system that outperformed civilizations with supercomputers and materials science. Sometimes, the deepest knowledge isn't written in technical journals. It's carried in standards passed from one generation to the next. If you've ever inherited a craft from a mentor, something they couldn't fully explain but knew worked, you understand exactly how this kind of knowledge travels. I'd be curious to hear those stories in the comments. Step back from the details for a moment. 2 worlds, different eras, same engineering challenges, same mortal stakes. One built a culture where quality was identity, where a road's construction was a matter of state pride, where inspectors enforced standards through public accountability, not hidden audits. The other built highways and airports and bridges and left quality to the lowest bidder. And when the infrastructure crisis came, it found a nation perfectly prepared to receive it. Crumbling bridges, failing water systems, roads that can't survive a decade. The difference was never technology, it was systems thinking. Design prevented problems before they started. Public standards guided construction without compromise. And the natural world, the drainage, the geology, the materials, became part of the solution. That's not ancient. That's a civilization that understood infrastructure is a culture, not a contract. If what brings you here is the real story, how these people actually built, what they valued, and why their standards solved problems that defeat billion-dollar budgets, then this channel was built for you. Subscribe, and you'll see what comes next. The next time you drive over a pothole without thinking about it, consider this. 2,000 years ago, a stonemason knelt beside a basalt block and fitted it perfectly into place. He couldn't explain why perfection mattered beyond his lifetime. He just knew it kept the empire moving. That knowledge, quiet, habitual, carried in the hands, outlasted every shortcut that replaced it.